Okay, this video is going to be pretty fun. It's another one of those summary of the whole course so far videos. I'm going to work through a complicated function design, not the whole design actually, just a re-implementation of the function. I'll probably do it faster than you can do it, but you might want to try watching it and then doing it by yourself, because as I say, it's really a summary of the whole course. So here we are in V7. And the problem we're supposed to do is to design a new function definition for same house as parent that is tail recursive. And it says we'll need a work list accumulator. And we'll actually need more accumulators than that. So here we go. What we'll do is we'll comment out the old version and we'll start templating the new version. And let's see, we're going to template it. And how are we going to template it? First, we're going to use the template from Wizard, which we know is the arbitrary arity tree wrapped in a local. So let's go get that. There it is right there. And we'll put it there and we'll rename it to same house as parent. Now, we need to do a tail recursive traversal of an arbitrary arity tree. So we know we need a work list accumulator. So let's add that to the template next. Make a note of that there, and let's see, let's go ahead and put that work list accumulator here. First we'll add the parameters, so I'll put it there, to do. In the arbitrary arity tree work list, the function that operates on list just gets its existing list parameter renamed like this. So now I've added the parameter, I've renamed the parameter. The initial value is going to be something. Will probably end up being empty, but I'll just put dots there for now. And now what happens here is that where we used to just pass the kids, we're going to append something having to do with the kids onto to do. And the reason I'm putting this ... around whiz kids is we know from our picture, remember the picture right here, the work list entries are going to be more complicated. They're going to be compound. So there we've got that parameter. Now let's see, we also need to make it tail recursive. So what I'll do is I'll just pull this into a comment of some sort to say, hey, you know, you might want to use this. And I'll leave that in tail position. Okay. Now I need to make this tail recursive. And the way you do that is we just make the work list argument. We call fun for whiz with the first thing in the to-do list, and the work list argument becomes the rest of the to-do list. And all this goes away. So now we're tail recursive. So now we've got a proper work list accumulator. Oops, there's one thing I forgot to do, which is to put the accumulator type in invariant. To do is, well, what is it? It's going to be a list of something because we know it's a work list. We'll leave that out for now. A work list accumulator. And now that we have this general notion of a work list accumulator, I can just put work list accumulator there. I don't have to sort of elaborately specify exactly what it is. You know what a work list accumulator is. Okay, but this function is going to build up an elaborate result. It's going to build up a list of wizards that are in the same house as their parent. In order to do that in a tail recursive way, we also need a result so far accumulator. So let's say added result so far accumulator for tail recursion. And let's see, first you add the parameter, and I'll just add it at the end of the parameter list, RSF there. And it goes to both functions, there and there. And it has to have some initial value, which will probably end up being the empty list, but we'll see that in a minute. And in fun for LOW here, we're now going to add the two argument expressions. It's going to be something, something, something dot RSF. And here it'll be something, something, something RSF, like that. Now we've got the RSF accumulator added to the code, and let's put the type and invariant. RSF is, well, if it's a result so far accumulator, if it's a true result so far accumulator, then it'll end up having the same type as the function produces. So we can just grab that from up here, list of string. Now sometimes you get a result so far accumulator where at the last thing you have to do something to it. It's sort of an almost result so far accumulator. So that might change later, but we'll see. A result so far accumulator. So now we've got the accumulator, we added the parameter in two places, we added the initial value expression, and we added the argument expression in two places. Now we're not quite there yet because we've got this work list accumulator, but if we remember to look at our picture, our work list entries are compound. Each work list entry has both a wizard and that wizard's parent's house. So let's do that. And what I'm going to do here is do something we haven't done before, but I'm going to go ahead and take advantage of the fact that local lets you put local defined structs. So I'm going to call this structure WLE for work list entry. Because it's a locally defined struct, I don't need to give it a really good name. I need to give it a name that's only kind of good enough to use locally. So let's see, each work list entry is going to have a wizard and a parent's house, and I'll put a type for it. WLE, or work list entry, is make WLE wizard and string. And again, looking at our picture, the way I'm going to interpret that is that it's a work list entry with the wizard to pass to fun for whiz, and that wizard's parent house. And what writing that does is it makes it clear to me I left one thing out here in fun for whiz. There's another parameter to fun for whiz, which is the parent's house. It isn't quite a context-preserving accumulator. Instead, it's context preserved in the work list accumulator entries. So that's going to be right there. The parent house is going to come in there. And that means that what's happening here is we're not passing the work list entry itself. We've got to pass the WLE of W, in other words, the wizard of the first work list entry. And we also have to pass WLE PH, in other words, the parent house of the first work list entry. Now that's kind of unpacking the work list entries. I've also got to pack up the work list entries. There was something that was going to happen here to whiz kids. And what has to happen here is that for each kid in whiz kids of W, I have to make a work list entry. For each kid in whiz kids of W, I have to make a work list entry. That's a map. So that's map for each kid in whiz kids of W. There's the end of the map here. So what do I have to do for each kid? Well, I have to make a WLE, an entry on the work list, with that kid and the current wizard, in other words, W's house. That says we make a wish list entry for this kid, but the current wizard's house. So So we're going to take that map, we're going to append it to to-do. So here you can see what's happening. Here we're making the wish list entries. They're compound data with a wizard and the parent's house. Here we're unpacking the wish list entries, taking out the wizard and the parent house. So let's put here that what we did was we added compound data definition for wish list entries. Let's make sure we've got the to-do accumulator finished. Let's see, here we're adding entries to the work list. Here we're unpacking the work list and taking the rest of the work list. Now we need to provide the initial value of the work list, and I made a mistake here. This actually belongs here because Fun4Wiz consumes the work list as its first argument. And what's the initial value of the work list? Well, the way we do them, work lists tend to start out empty. So that's the work list. Okay, let's do the RSF. Well, the RSF is the result so far. And each time we're in a wizard, we need to decide, does this wizard's name get added to RSF? And it gets added if this wizard's house is the same as the parent house. So there's an if. And then we're going to do some stuff with this. I'll just copy it all down here so I can work with it. And I'll copy it twice. And the question we're going to ask is this parent's house, is this wizard's house the same as the parent's house? And if it is, we're going to cons this wizard's name onto RSF. And if it isn't, RSF won't change. So there we're building up RSF. Here, if there's nothing left to do, we just produce RSF. That's what happens with an RSF accumulator. And Fun4LOW, as is often the case, doesn't change the RSF accumulator. It just passes it along. Now, the RSF accumulator starts out as empty because it's list of string. And there's one thing missing here. Remember when we added pH as a parameter to Fun4Wiz? We forgot to add, or I forgot to add, it wasn't your fault. We forgot to put dots there to remind ourselves to provide the initial value for pH there. And what is the initial value for pH? Well, we decided a long time ago that the parent's house for the root of the wizard tree was the empty string. I hope this works. Oops, one test failed. AFE differs from EFA. Well, you know why that is, right? When you do a tail recursive operation to produce a list, you tend to get the result in a different order than when you do a non-tail recursive operation. These have the same elements in them, they're just in the opposite order. There's two ways to fix it. You could either change this cons to flip the arguments and use append, or you could just go up here and decide that this function is now going to produce these in a different order. Either of those are fine. If you had a large code base that was relying on this function, you would probably switch down here to using an append. Let's try it now. Now look, there's a super important point here. There's a super important point here. And that is that code is more than just a bunch of characters. Code has structure. That's a large part of what you've learned so far in this course. We use the word template to talk about some of the elements of that structure. It's because I was able to think in terms of that structure that this function was easy to write. Because first I said, okay, well the template, in other words, some kind of structure, comes from wizard, an arbitrary arity tree. And I'll wrap it in a local. And I'll add a work list accumulator. And I'll add a results so far accumulator. And I'll add a compound data definition for wish list entries. and then I'll fill in the details based on what this exact function has to do. When I write this code and when I read this code, instead of seeing it as a whole bunch of characters, I see it in terms of these different kinds of structure. And that makes it easier for me to understand and also easier for me to write. And that really is one of the big lessons in the way that this course has been trying to get you to think about programming, is that that's how you want to think about it too. Because otherwise, this little function of less than 20 lines could be overwhelmingly complicated. Instead, it's really not. I would suggest that you now go and try to do that whole development by yourself without watching the video, or do it with starting and stopping the video. This really is the great review of the whole course so far.